Okay, this is a short discussion on problems 23 to 32 in the homework set for 6.4. These are interesting problems because you see different waves. We have to match these equations with their graphs. Looking at the equations, I notice a number of things. For example, if you look at 23, 24, and 30, okay, all three of these, you have an amplitude of 2. You can see the 2 with the coefficient out in front here, sometimes positive, sometimes negative. Remember, amplitude is the absolute value of that. And you can also see the same omega number. Remember, the omega number is the multiplier of the angle there. And in all three of these, it's pi over 2. So when we discuss these, we'll discuss these three at the same time, try to find the appropriate graphs. The other thing I note when I look at these 10 equations is that a number of them have 1/2 x. So 25 and 28, again, the amplitude is 2 in each case. And if we go down here to 29 and 32, the amplitude is also 2. These are negative 2s. The amplitude is the absolute value of that. And in each one of these, the multiplier, the omega number, is 1/2. So they all have the same period. They all have the same cycle. They all have the same wavelength. So we'll discuss those 4 at the same time. And lastly, the remaining 3 all have amplitude 3. That would be 26, 27, and 31. Okay, they all have amplitude 3. And the angle, the multiplier there, is 2. So in each case, we see a 2 there. So that these also will have the same cycle, same period. So I think if you sort of look at the choices to begin with, it makes it a whole lot easier to figure out which graph matches with which equation. Okay, so with that in mind, let's look at these first 3. Now remember, we've said the amplitude is the multiplier there. Amplitude is 2 in each case, right? It's the absolute value of 2. So absolute value of 2 there, absolute value of 2 there, absolute value of 2 there. But in all cases, the amplitude is 2. The period or the wavelength or the cycle, all means the same thing, is always 2 pi divided by omega. And for all 3 of these, we have 2 pi divided by pi over 2, which is the same as 2 pi times 2 over pi, which is equal to 4, right? Because the pi's cancel. So we have a period of 4. And then obviously 2 of these are cosine waves. These are cosines here. And this is the sine wave. So let's attack the sine wave first. We want a sine wave. Notice, by the way, that if the number out in front is positive, then we're going to claim that this is a right side up. That's sort of a weird way of saying a right side up sine wave. We know sine waves pass through the origin. So this particular one here will be going through the origin, going like that. Okay, so we're looking for a right side up sine wave with an amplitude of 2 and a period of 4. Here's our choices. Okay, right side up sine wave. That's not a sine wave. This one is, and we do have an amplitude of 2. Is the period 4? Well, no, the period is 4 pi, so that's out. So let's see, that's not a right side up sine wave. This is an upside down sine wave here. That's not sine. This is a right side up sine wave, and the period is 4 and the amplitude is 2. Good. So the choice is F. So for this one, we have choice F here. F. Okay, the second one, we have a right side up cosine wave this time. Notice the 2 is positive, so this is right side up. Right side up. Cosine waves look like this, right? Remember, they're going like that. So right side up, amplitude 2, and period 4. So here's our choices. Let's see. Right side up. Now we've already taken care of this one, right? So that's already out of the picture. Right side up cosine. That's not cosine. Ooh, this is a cosine. Let's see, cosine, but here the period is 4 pi again. We want 4, so that's out of the picture. This is an upside down cosine. Don't need that. That's a sine. This is a right side up cosine, and sure enough, period is 4. So that would be E. Okay, so choice E for problem number 24. So this is E. Right side up, cosine, amplitude 2, period 4. Okay, third one, or number 30, which is actually deeper in the problem set, but since it has the same amplitude and period, we'll look at this. Okay, so again a cosine wave, but now it's upside down, right? So the upside down is caused by the negative coefficient here, upside down. So what we're thinking of is a regular cosine wave looks like that. So upside down is going to start down at the bottom here and go like that. Okay, so we're looking for an upside down cosine wave, still amplitude 2, still period 4. Okay, so we've already got these guys taken care of, right? So we've already chosen these. So those are out of the picture. Let's see, upside down cosine. This is upside down cosine, but the period's 4 pi, so that's out. Let's see, this is a sine, that's out. That's a right side up cosine. That's an upside down sine. This one here is an upside down cosine, and the period is 4, and the amplitude is 2. So this is the one we want right here. So that's choice G, right? So G is going to be for that problem number 30, okay? So this here we know is G. Okie doke. So that same type of analysis, find the amplitude, find the period, determine whether it's a sine or a cosine, and right side up or upside down, will work for all the problems. Okay, so here's the next batch. I noticed on all of these, the amplitude is 2, right? So we see the 2 again, amplitude 2. But the period now, they all have that multiplier of 1/2. So it's 2 pi divided by 1/2, which is 2 pi times 2 over 1, which is 4 pi. So all of these have a period of 4 pi, amplitude of 2. And you notice that 25 and 28, these are right side up, right? So I'll call these right side up. And these guys over here are all going to be upside down because the coefficient is negative. So upside down. If I just do a quick little sketch, an upside down sine wave is going to go like that. An upside down cosine wave is going to go like this, right? The right side up cosine wave, we know starts up high here and goes like that. And the right side up sine wave, we know goes like that. Okay, so those are the pictures that we're looking for. They all have period 4 pi. Let's just go right down the line. 25, we want a right side up cosine, amplitude 2, period 4 pi. Right side up cosine, amplitude, well, this is amplitude 3, so that's out. Amplitude 2, let's see, right side up cosine, amplitude 2, this looks like the one right here, okay? So right side up, cosine, period 4 pi, amplitude 2, perfect. That's the one that goes with number 25, okay? So 25 is A. Let's use a blue one for that. 25 is A. A. Okay, how about right side up sine wave? Again, and we're doing 28 now. Right side up sine wave, amplitude 2, period 4 pi. Right side up sine wave. Okay, so this is a sine wave, amplitude 2, period 4 pi. So that's good. This is the one we want. And that was number, I wish I had it all on the same sheet. That was number 28. So this one's good for 28. Choice B. Right. Okay, 29. Now this is an upside down cosine wave. Upside down cosine wave looking like this. Amplitude 2, period 4 pi. Upside down cosine. Here we are, right here. This is it right here. There's the period. Yes, it's upside down, so that's choice C. So this is choice C here. And the last one there is the upside down sine wave, amplitude 2, period 4 pi, upside down sine wave. These are getting fairly easy because fewer and fewer choices. There's my upside down sine wave. Note the period of 4 pi is missing here, but it's between 3 pi and 5 pi. So sure enough, 4 pi, upside down sine wave, amplitude 2, period 4 pi. So that's choice D as in delta, and that's here, D. Okay, and obviously the last three were the ones with amplitude 3. So all these had a multiplier of 3 out in front. This one we'll note is an upside down sine wave passing through the origin, right? But instead of going in the first quadrant, it goes down to the fourth quadrant like that. Okay, upside down sine wave. This is a right side up sine wave. So this is going to look like that. And this is a right side up cosine wave. Okay, so that's going to look like that. All with amplitude 3. So 26 is right side up cosine. And again, there's just a few choices left here. Right side up cosine, that's going to be this one. Okay, so that's choice I. Notice the period. Oh, we never did calculate the period on these. Maybe we should go back and look at those just to confirm. The period on all these, period, is 2 pi divided by omega, which is 2 pi divided by 2, which is pi. Okay? Right, because the multiplier in the angle in all of these is 2. So yeah, period of pi, amplitude of 3, right side up, cosine, number 26. And sure enough, right side cosine was this one here. This is 26. Right, the period is pi. That's the distance from wave top to wave top. That's pi. And the amplitude is 3. So we have everything that we need here. That's choice I. Oops, this is I. Okay, this is the upside down sine wave for number 27. Upside down sine wave. Amplitude is 3. Period is again pi. So we look at the choices. Upside down sine wave. Period pi. From here to here is pi, right? And the amplitude is 3. So we see that. That would be this one here, what, 27, right? So this is 27, we got that. And then the last one, which was 28, has by default going to be this J problem here, but let's just confirm. Sure enough, we see the amplitude. Oops, it wasn't 28, it was 31. Okay, so it was the amplitude of 3, and the period was pi. So right side up sine wave, good. Amplitude of 3, and period is pi. Right? So this is pi right here, halfway between 3/4 of a pi and 1 1/4 pi is pi. Okay, so that's J. Good little exercise. I know the evens were not in the back of the book, so I wanted to sort of discuss all of the you saw on the solutions that I posted, the answers, but I wanted to go through the thought process on how you might do these. I hope that helped. We do tangents coming soon.